Okay, so we will only spend one day on this lesson, lesson 2.2, solving inequalities by adding and subtracting. So when we're solving these one-step inequalities that require the inverse operations of addition and subtraction, the same rule applies as if we were solving an equation. Yeah, nothing is different. You just follow the same rules you would do if you were solving equation of that type. So we know the rules for undoing addition and subtraction when solving equations. Typically what we don't do when we solve equations is we typically do not graph them because typically they only have one solution, don't they? So if we graph them, does anybody know how you would graph a one solution answer? How would we graph that on the number line?
Just black dot.
Yeah, just a point, a dot, a circle shaded in at that value on the number line. Nothing else would be shaded because it would be the singular solution. So we don't have anything. But when we're talking about inequalities, we know that the solutions, there's an infinite number of solutions. And so we have to show them a different way. So we do show it with a graph also. So solve and graph the solution. Well, we need to get x alone. That's always our goal, right? In solving equations in algebra, get the variable alone. So what are we going to do? Add what? 2, did you say? Or 6?
Add 2.
Add 2 because it's the x we want alone. We don't want the other side to become 0 necessarily for any reason, do we? So negative 6 plus 2, negative 4 is greater than x. So this is also known as, and I think they had you do this in your homework for today, this is also known as, let's reverse that so that the variable's on the left side. What would that be also known as?
X is less than negative 4.
Yeah, x is less than negative 4. So basically, we're gonna graph it down here, but negative 4 greater than x says what? Negative 4 is greater than, just like the symbol says, negative 4 is greater than, negative 4, remember, is our starting point. So they're saying our starting point of negative 4 is greater than all the values that x can be. So let's visualize that. If negative 4 has to be greater than all the values x can be, negative 4, I'm just going to go to my number line here, negative 4 has to be greater than all the values x can be. Give me some examples of some solutions for this inequality.
Negative 6.
Negative 6. Is negative 4 greater than negative 6?
Yes.
Yes. So it's kind of looking like right now, if we were going to graph this on the number line, which side of the starting point would be shaded, the left or the right? The left. Okay, well let's see if when we reverse it and write it the other way, if the same thing holds true then. When we do reverse it and have x is less than negative 4, that says all numbers that x can be, because x starts out the statement, all the numbers that x can be are less than negative 4. So anything you want to grab from the solution region better be less than negative 4 is what that is saying. So again, we look up here, we say, here's our starting point. What are all the numbers that are less than negative 4? Which direction are they from negative 4? They're to the left. So no matter which way we read the statement, we still have the same solution region, or we better, right? Okay, so we're going to have negative 4. Closest integer neighbor to the left? Negative 5. Closest integer neighbor to the right? Negative 3. And trust me, there are oftentimes we mess that up. We think 1, 2, 3, going from left to right, so we do the same thing over here, 1, 2, 3 in negative territory, but it doesn't work like that, does it? Okay, open or close circle at negative 4. Because why again?
Not equal.
It's not included. Yep, negative 4 is not in the solution set. And we have decided that all of the ones to the left of it, all the values less than negative 4 need to be in the solution region. Okay, now, We need to know how to check these, even though I know you don't do check problems very often, and I'm not requiring you to do them. I should, I think. Because you know what? I was really disappointed when I give you a multiple choice test, like I did in chapter 1, and you worked out the problem, and you were just happy as could be when your answer was in the answer bank. But yet when I corrected it, I marked it wrong. Where you're like, well, wait a minute, but that's what I got, and it was there, so why is this wrong? If you had put your answer back into the equation and checked it out, you would have found out you were wrong. You probably made some silly little mistake along the way somewhere, like forgetting to carry down a negative sign in your work or whatever, and you would have found out, oh, well, yeah, this is what the answer should be, and that answer is also in the answer bank. Trust me, when they write, even I can do this as a math teacher, when we write math tests, multiple choice math tests, we know where you're going to make your mistakes. And we work it out making your mistakes, and we find those answers you're going to get, and we put them in the multiple choice answer bank. So, that's why it's important to check your answer when you get it, because especially when you're taking a multiple choice test and you have the choices there for you. Because if yours doesn't check out, then you can be like, well, I got 3 other answers to choose from. Maybe I should try again. Okay? So if we were going to check the solution, this is for an inequality now. We have 2 checks to do. We have to check to make sure, first of all, we have the right endpoint. We have to have the right starting point. Okay? And then we have to check to see, did we shade the correct side or not? Or did we shade the correct region? So our first part of our check problem would be replace the inequality symbol with an equal sign. So here's what we're going to do. We're going to take our inequality, which was -6, is something. We're going to put an equal sign there. And then wasn't it -2 plus x? Am I right? Okay. And we're going to substitute into that our endpoint that we got. What do we think the endpoint is, the starting point? -4. So we're going to put that in there for x. All we're doing right now is checking the endpoint. Make sure we got that right. Well, -6 is -6. Equal sign is equal sign. But now we can combine -2 and -4, and what do we get? -6. So it checks out. We're going to write here in our notes, the endpoint checks out. Or we'll just say endpoint checks. The endpoint checks. We got to make sure we have that right, because it's easy even to get that part wrong. Okay? Even not so much in these problems because they're fairly basic, but it is easy to get them wrong. Okay, now it says in part B, it says, then we would check a number from the shaded region in the original inequality. So we're going to write down the inequality as it was. What symbol is there? What's the symbol in it? Is greater than, okay? -2 plus x. So now we're back to our inequality statement. We're not checking the endpoint anymore. We're now checking to see, do we have the correct side shaded or not? Okay? So tell me, give me a number from our shaded region that we can check out in here. -2 is -2 in our shaded region? Let's go back up, let's look. Is -2 in our shaded region? No, what is? -5 is, -6 is, -1 million is, whatever you want to check, right? Okay, so which one do you want to do? -5. -6 is greater than -2 plus -5. Well, -6 is -6. Is greater than is greater than. We're not going to change that. But we can combine our -2 and our -5. And what's that? -7. So now we have to determine, is our inequality statement true or false? It better be true, or we've shaded the wrong region. Is it true?
Yes.
Is -6 greater than -7?
Yes.
Yeah. So we can say checks. If we end up with a true statement, so we're going to say shaded region checks. And in reality, there's only one way to check to see if you have the endpoint, whether it should have been shaded or not shaded. You would have to do a third checking where you would put the inequality, you would put the endpoint in, in the inequality statement, and here's what should end up happening. You should end up with -6 is greater than -6. Is that true? No. So if it isn't true, what does that tell us about that endpoint? Should it be shaded or not shaded? When we're checking it. So we're going to put the -4 in, the endpoint into the inequality. Here's what would happen. We put -4 in for x, we'd end up with -6 is greater than -6. True or false?
False.
If it's false, that means it's
Not shaded.
not a solution. It better not be shaded. And did we shade the endpoint? Did we shade the endpoint? No, we did not. So we could do a third checkpoint, but we're gonna trust that we're smart enough to realize that when the equal to bar is not there, don't shade it in that endpoint, right? Okay. Okay. Anybody got questions? So I'm not requiring you to do check problems, but by some of the tests that I corrected on the chapter 1 test in solving equations, I'm thinking you guys should be doing some check problems on your own. You should have your own incentive to do it, not because a teacher is making you do it. Okay, let's go to the back side. Okay, go ahead and solve that one and graph it, and you decide if up in the white space above it you want to do a check problem for. Your call. Okay, do you agree with my solution? Yeah? Okay. Well then let's graph it. What integer neighbor is closest to the left?
3.
3. Okay. So I'm just gonna be random and stick a 3 there. Okay. How about the closest integer neighbor to the right? 4. So can I just put 4 right here?
Sure.
What do you think?
Maybe we'll.
Probably a little bit further over, because is 3 and 3/10 exactly halfway between 3 and 4? No, it isn't. It's less than halfway, so we have to have a better number line going on there. So we're going to, this is 3/10, so I'm thinking, okay, there's another 3/10, another 3/10, and then I need a 10, so maybe about right there. That look more reasonable? Okay. Because one of them has a distance of how much? The first little segment in here, this little segment has a distance of how much? 3/10 of a unit. And this one has a distance of how much? 7/10. So, yeah, that's more than twice as long as the other one. So again, we have to make sure we're reasonable. Okay, what kind of a dot should I have at that end point? At that starting point? Solid. Yeah, so a closed in, shaded one. And what direction should we shade? To the right, okay. Anybody do a check problem? Did you? Okay. Did it check out? Yep. Are we safe with our answer? Okay, cool. Anybody got any questions about it? These should feel pretty basic, don't they? Yeah? Okay. Well, next we're going to do an application problem. We have one here where we have an elevator. And the maximum load for this certain elevator is 1 ton. Oh, by the way, does anybody know how many pounds there are in a ton?
2,000.
2,000. Good job. It's a good thing you know that, because I think it's going to be important. The total weight of the passengers on that elevator is 1,400 pounds. So there's a whole bunch of people on this elevator already, and altogether they weigh 1,400 pounds, 1,400 pounds. A delivery man who weighs 243 pounds enters the elevator, so he wasn't on it yet, but he's coming on, and he has a crate that weighs W pounds. Write, solve, and graph an inequality to show the values of W that will not exceed the weight of the elevator. In other words, the people who are already on that elevator should be a little bit concerned. He comes out with a crate. They see his size, and they say this crate that, I think that looks like it's too big. I might want to get off this elevator. Okay, so first thing we got to do when we're doing application problems and we're going to set up our own inequalities, we have to define the variable. So So what's our variable representing?
Somebody can always think of a weight.
Yeah. W is the weight of crate in what? Tons?
Pounds.
Pounds, okay. The weight of the crate in pounds. That's what our W in our, even though they already told us in that, it says the values of W, but we need to, really define that for ourselves. Okay, anybody think they can help us set up an inequality statement that would help us come up with good weights for this crate? Jacob?
W plus 243 plus 100, 1,400 pounds is less than or equal to 2,000.
Okay. Let's evaluate this and see if we think this will work. W is the weight of the crate, right? We said, in pounds. 243 is the delivery man's weight. He's coming on the elevator. 1,400 is the weight of all the people already on there in pounds. And then is less than or equal to, that tells me that at most, it better be 2,000 pounds. Is that the way this situation is? At most, we can put 2,000 pounds on this elevator. And the 2,000 pounds comes from what? The 1 ton. We had to convert that into pounds, didn't we? Okay, go ahead and solve that inequality. And let's see how much that crate can weigh. So do you get that at most, the crate can weigh 357 pounds? At most, it can weigh 357 pounds. So that's a pretty good sized crate. We don't have much to worry about around this elevator, right? Okay. Well then, we got to also take into account that in reality, W would actually have to be what? There's a kind of a restriction here. What can't we really have?
We can't have a negative weight.
Can't have negative weight. So we want where W is non-negative. Where W is non-negative because weight is not measured in negative values. Just like distance isn't measured in negative units, either is weight measured in negative. There's such thing as negative time, negative weight, negative distance, those kinds of things. Okay, so when we graph this then, do you remember yesterday when we said there's really kind of like a restricted area? We would start at 0. We would end at 357, and the crate can weigh somewhere in between that, correct? And then we also have to decide, can it weigh 0 pounds? What do you think? No. Not really, because if there's a crate, there's already weight, isn't there? So we would probably put an open circle at 0, and then how about at 357? Can it weigh 357 pounds? Yes, it can. The equal to bar is there, so it can weigh that. So our graph would look like such. Anywhere from greater than 0 pounds up through 357 pounds. Okay, any questions? Like what are the kinds of things you need to show for these application problems? Okay, then there's an interesting little exercise they have you do in your homework that I'll practice with you because otherwise you'd probably be lowering your hands up in the air and saying, Mrs. Brandon didn't have a clue what to do. So let's do this one. Use the inequality x minus 4 is less than 10. Use that inequality statement to complete the following inequality statements. We are looking for x is less than something. So, in other words, it went from the inequality statement being, let's write it down here, it went from the inequality statement being this to the x being alone. So what do you suppose we're going to do? Add 4 to both sides, absolutely. If we add 4 to both sides, the x will be alone. The inequality symbol will be the same as it was. Thank goodness. And now we know that the fill in the blank is 14. Okay, why don't you try the next one on your own? Try B on your own. See if you can get that one figured out. Okay, anybody want to offer up what they think the fill in the blank answer is? Abby?
1.
You think it's 1? Okay. Anybody want to agree with Abby? She says it's 1.
It could be a bunch of stuff.
Could be a bunch of stuff. Okay. You think it really could be just anything? So if Abby wants 1, she can have 1, and if you want another value, you can have your value. Okay, notice what I did. I wrote down the inequality that we were given. Are you feeling like that's useful at all? Or did you use something else? What did you do to get your 1, Abby?
Well, like, x, like, it can't be more than 14. And so if it was like 10 minus 14 is like -2. And so I just put 1 because 1 is more than -2.
Okay, but remember, it's in relationship to this. So it has to stay in relationship to this one. And in reality, because we were doing this one, this is now in relationship. It's in the same category. They're in the same group that they all have the same solution set in reality. So this has the same solution. The original one has the same solution set as our one right here in A. And now we're trying to find another one that would actually have the same solution set. So we could use, possibly we could use this one, or we could use our original one, or, so Jacob?
I think the solution would be 0.
You think the fill in the blank is 0. It's not really the solution, but the fill in the blank is 0?
Fill in the blank.
Okay. Anybody want to agree with Jacob that maybe it's 0? You got Abby who wants 1, Jacob who wants 0, and the rest of you don't want anything? Okay, let's hear some other offers then. By the way, let's go back to Jacob for a second. Jacob, how did you get that?
I took x minus 4 is less than 10, and I subtracted 10, and I got x minus 14 is less than 0.
Looky here. When he takes 10 away from both sides, look at what happens on the left side. We end up with x take away 14, and isn't that what we want? Isn't that what we want? Is x minus 14 there? Well, we got it, didn't we? And now our inequality symbol comes down, and what's 10 take away 10? 0. So guess what? Jacob's right. The fill in the blank is 0, and it's the only one it can be. To be in relationship. We're just naming all different kinds of inequalities that would have the same solution set. And by the way, that solution set is what? What is that solution set? It's an A. What is the solution set? X is less than 14. That's the solution set. So when we solve our x minus 4 is less than 10, we would get x is less than 14. If we solve x minus 14 is less than 0, we would get x is less than 14. Okay, well now go ahead, now that you kind of maybe get a better picture of it, go ahead and try C on your own. This is the most challenging of the 3. You can get C to work out. Again, here's how you know whether you have a good answer or not. If you solved your inequality that you end up with, you should get the solution set x is less than 14. So if you solved your inequality, after you did your fill in the blank, would you get x is less than 14? Volunteer to come up here and do it for us? Okay, Jacob. Use your finger, but hold my pen, okay?
Okay.
Okay.
I took X. And then I add opposite. And add 6 to both sides.
You want to tell them why you're adding 6 to both sides?
Well, this is 16, and if I can add 6 to both sides because I can do anything to both sides.
Right, exactly, as long as it's the same thing on both sides, right? Okay.
So then x plus 2, 16.
So fill in the blank is, go ahead and put it up there.
Fill in the blank is 2.
Okay. Anybody want to ask Jacob any questions? So again, Jacob, what was the reason that you decided to add 6? Because I think they're wondering why did you just pick some number out of the sky or what?
Well, the base solution is x minus 4 is less than 10, and there's 16. So I added 6 to 10 to get 16.
Yeah. So it starts right there. He says, you know what? I needed 16 on the right side. So what do I have to do to that 10 to get it to become 16, right? Got to add 6, don't you? Well, if you add 6 on one side, what do you have to do?
I have to add 6 on the opposite
You have to add 6 on the other side. Good job, Jacob. That is the answer. Okay. How many of you had that? Do you see now how to get it? You are going to have to do this in your homework. It's challenging, isn't it? It makes you think. Okay. If we solve this now, if we actually solve this now, tell me, would we get x is less than 14? Let's take away 2 from both sides, right? Would that be how we solve it? Take away 2 from both sides. X is less than 14. We get what we want to get. Oh. Do you have questions that you can even think about asking with this one, or are you kind of still just trying to muddle it around in your head? You can do it! You can. Okay.